All right, guys, let's look at 9.3 notes. Sometimes probability of an event changes after an outcome happens. This is called dependent. Suppose you draw a card from a deck of cards. They're numbered 2 through 10. Each suit has an ace, king, queen, and jack. First, the probability that I draw a heart. Well, fourth of them were hearts, so 13 out of 52. If I keep the card and draw another, the probability that I get another heart has changed. There's only 12 hearts left, and then there's only 51 total, so 12 out of 51. Example 1. Suppose that I draw 4 cards without replacing. What is the probability that I draw all 4 red cards? So red, 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 red. Well, first red card, 13 out of 52. Do not replace it, 12 out of 51. Second card's red, 11 out of 50. Third card's red, and finally 10 out of 49. Fourth card's red. Calculator 0.0026 or 0.26%. Okay. What's the probability, same situation, 4 cards without replacing, that all 4 cards are not aces? Okay, so first card's not an ace, so 40 out of 52, 47, 51, 46, 50, and 45, 49. Okay, mathematics in your calculator, 0.7187 or 71.87%. 4 cards, none of them being aces. All right. What is the probability? The fourth card is the diamond. Okay, so no diamond, no diamond, no diamond, fourth card, diamond. Okay, first card, not a diamond, 39 out of 52. Second card, not a diamond, 38 out of 51. Third card, not a diamond, 37 out of 50. And then finally, the fourth card, yes, a diamond, 13 diamonds left out of 49 total cards. Do the math, 0.1097. Okay, make sure we're paying attention to the language when we pull multiple sections together. Could be independent, could be dependent. All right, well, final question on the deck of cards. What's the probability you get at least 1 club? Okay, well, this is what we've talked about, is when you have the language at least, it gets pretty difficult. That means it could be 1, it could be 2, it could be 3, and it could be 4, and all the combinations that those could happen. So if you do this straight probability, then it will be quite difficult. Not impossible, but quite difficult. So we're going to do the complement. Okay, so the complement of at least 1 club is the opposite. Okay, 1. So if I find the complement, I can say the probability at least 1 club is equal to 1 minus the opposite, which is the probability no clubs. Okay, so 1 minus no club, no club, no club, no club, 0.6962. Probability at least 1 card will be a club. Okay. Other times it's easier to make a tree diagram to help answer probability questions. Okay, so here's an example. It says a new drug test on the market claims that 15% of its customers test negative for illegal drug use, and of those who test negative, 3% have actually used illegal drugs. Of the people who test positive, 8% have actually not used illegal drugs. Okay, all right, so we have the test, and there's 2 possibilities of the test. You could test negative, or you could test positive. Okay, so we have 15% or 0.15 negative, 0.85 positive. Okay, of the people who test negative, 3% used and 97% did not use. Because if 3% actually used drugs, then 97% of those. So that subcategory or that branch of the tree has to add up to 1. Of the people who tested positive, they tell us, 8% not used and 92% actually used. Okay, so then to get some individual compound probabilities, we would multiply these. So if you test negative and used, it'd be 0.15 times 0.03, 0.0045. If you test negative but didn't use, 0.15 times 0.97 is 0.1455. If you test positive but you actually did use, 0.782. If you test positive and you didn't use, 0.068. Multiplying those together. Okay. All right, so now we can answer some different questions. Okay. We have all the math we need. It says, what is the probability that a person tests negative when they didn't use illegal drugs? Okay. So test negative, did not use. That's that 0.15 times 0.97, 0.1455. Again, just like a lot of things in this class, the reading is very important. B, what's the probability that a person tests positive when they actually used illegal drugs? Well, test positive, 0.85, and actually used, 0.92. That's the 0.782. Okay. Last one, if you know someone's using drugs, what's the probability that they will test negative? Okay, so test negative and that they actually use drugs. Well, there's two possibilities where they actually used. Okay, the negative and used, so that's 0.045, or positive and used, 0.782, so all of that's on my denominator, okay? And then they test negative and actually used is 0.0045, okay? Put in your calculator, 0.0057. That's the probability that if someone is using drugs, they will test negative, okay? So 0.57%. That's a very, very small probability that if you're using drugs, you're going to actually test negative, okay? It's hard to beat the test. All right, next page, example 3. It says, one morning it's so dark you cannot see in your sock drawer. You know that you have 12 black socks, 6 white socks, and 2 red socks. You're hoping to find 2 white socks when you reach blindly into your drawer and pull out socks one at a time, okay? Well, 20 total. Okay, 12, 6, and 2. So first question, what is the probability you get 2 white socks with the first 2 socks that you choose? Okay, well, white and white. So 6 out of 20 and 5 out of 19.0789. Okay, dependent probability. The event that is second is affected by what happened first. What's the probability that the first sock is the third sock selected? Okay. What's the probability that the first white sock is the third sock selected? So that means not white, and finally white. 0.1596. Okay. Third question, what is the probability that you choose for black socks? Black, 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 black. Well, 12 out of 20, first one. 11 out of 19, second one. 10 out of 18, third one. 9 out of 17, fourth one. Put in your calculator, 0.1022. Okay. And the last SOC question. What is the probability that you choose at least one of the 4 socks chosen is red? Okay, I'm going to do the opposite. I'm going to do 1 minus the probability that none of them are red. It's much easier. So 1 minus no red, no red, no red, no red, 0.3684, choosing 4, at least 1 is red. Okay. Let's look at example 4. It says 70% of kids who visit the doctor have a fever, and 30% of kids who have a fever also have a sore throat. 60% of kids who don't have a fever have a sore throat. What's the probability that a kid visiting the doctor is? And then we've got 4 questions to answer. Well, I'm definitely going to use a tree diagram here. All right. So, doctor visit. First, we have 2 possibilities. Fever, no fever. Says 70% of kids who visit the doctor have a fever, 0.70, 30% don't. 60% of kids who don't have a fever have a sore throat. So we've got sore throat, 0.60. This would be not a sore throat. It's got to be 0.40. It's got to add up to 1. And then we were told 30% of kids who have a fever also have a sore throat. So this would be sore, 30%, not sore, 70%. Okay. All right, now I do want to go ahead and multiply the compounds. So fever and a sore throat, so 0.7 times 0.3 is 0.21. Fever, not a sore throat, 0.7 times 0.7 is 0.49. Not a fever, but a sore throat, 0.3 times 0.6, 0.18. And finally, not a fever and not a sore throat, 0.3 times 0.4, 0.12. Okay. All right, well, what's the probability that has a fever and a sore throat? Fever and sore throat, that's that 0.21. What's the probability that the kid visiting doesn't have a fever or a sore throat? That's the 0.12. No fever, no sore throat. What's the probability that a kid has a fever if you know that they have a sore throat? Okay, well, this is more than one possibility. Okay, so fever and sore throat's 0.21. Okay, but if you know they have a sore throat, there's more than one possibility that they have a sore throat. So they could have no fever and a sore throat, which is 0.18, or they could have a fever and a sore throat, which is that 0.21. So that's the denominator. So 0.21 over 0.39, which is 0.5385. Okay, and the next question similar. What's the probability the kid has a fever if you know they don't have a sore throat? Okay, so the numerator is no sore throat, no fever. Okay, that's that point. No, has a fever. So fever and no sore throat, that's 0.49. And then there's 2 possibilities if you know they don't have a sore throat. So fever, no sore throat, 0.49, or no fever, no sore throat, 0.12, 0.49 over 0.61, 0.8033. Okay. All right, example 5 is actually a good one for you guys to try on your own. So pause the video, try it. Whenever you hit play, then you can check your answers. Okay, so I'll hit pause now. Okay, I hope you had success on example 5. Do your homework, check your answers, make sure you know why those are the answers. See you next time.